Welcome to EduRev.
Hello everyone, welcome to EduRev. My name is Khushbu Gupta and I am your chemistry educator. So today I am continuing with the part 6 of the topic Some Basic Concepts of Chemistry. So let's see what topics we will cover in this lecture. We will talk about stoichiometry and stoichiometry calculations. There will be a concept about limiting reagent. Then we will study about reactions in solution. Basically, we will talk about concept of solute and solvent. What are the concentration terms used when we deal with solutions like mass percent, mole fraction, molarity and molality. So let's begin this chapter. The first topic of today's discussion is stoichiometry and stoichiometry calculations. So this is very important topic, as if your basics are cleared with this topic, then eventually you will not be able to face any problem while solving any type of question. Okay. So first let us understand what is stoichiometry. So stoichiometry deals with the calculations of quantities of reactant and product इन्वॉल्व इन अ केमिकल रिएक्शन. सो एक केमिकल रिएक्शन में कितना रिएक्टेंट ने रिएक्ट करा और कितना प्रोडक्ट बना. ठीक है. अब दैट क्वांटिटी कैन बी इन टर्म्स ऑफ मास और इट कैन बी इन टर्म्स ऑफ वॉल्यूम. सो जनरली हम मास के साथ ही डील करते हैं, बट समटाइम्स वॉल्यूम्स आर आल्सो कंसिडर्ड. So in order to understand stoichiometry, let us first brush up our basics regarding a balanced chemical equation. So you know that the balanced chemical equation is that equation in which the number of atoms of an element on the left hand side is equal to the number of atoms of element on the right hand side. So before dealing with stoichiometry, first check that whether the reaction is balanced or not. So let's consider this reaction, which is the combustion of methane. So this represents methane plus 2O2 gives CO2 plus 2H2O. Number of atoms of carbon is 1. Here also it is 1. Total number of atoms of hydrogen are 4 in the left hand side, and here also it is 4. And total number of oxygens here is 4. And in the product as well, the total number of oxygen atom is also 4. So this equation is balanced, right? So whatever written on the left hand side of a equation are called as reactants, and on the right hand side of the equation we get the products. Okay. And whatever is written in these brackets, it represents the phases of the particular reactant. So here it is mentioned as a bracket small g, which represents gas phase. Similarly, solids and liquids are represented by small s and small l respectively. So the coefficients of these reactant and products represent the stoichiometric coefficients. Like in case of this reaction, methane has a stoichiometric coefficient of 1, oxygen has 2, carbon dioxide has 1, and water has 2. So these stoichiometric coefficients represents the number of molecules or moles taking part or formed in the reaction. इसका क्या मतलब हुआ? जैसे मैं बोल सकती हूँ कि मेरा 1 मोल मीथेन यूज हुआ टू प्रोड्यूस 2 मोल ऑफ वाटर. ठीक है. तो स्टोइशियोमेट्रिक कोएफिशिएंट्स आपको ये इंफॉर्मेशन देते. So in order to understand more, let us see how we will interpret this equation. We will say that 1 mole of methane reacts with 2 mole of oxygen to give 1 mole of carbon dioxide and 2 mole of water, as you can see from the equation, right? Similarly, हम बोल सकते हैं एक मॉलिक्यूल ने रिएक्ट करा correspondingly 2 मॉलिक्यूल ऑक्सीजन के साथ to give 1 molecule of carbon dioxide and 2 molecule of water. ठीक है. अब अगर मुझे in terms of mass देखना है, तो मेरा मोल क्योंकि 1 है, दैट मीन्स जो मेरा मोलिकुलर मास ऑफ मीथेन है, दैट विल बी इक्वल टू माय मास ऑफ गिवन मास ऑफ मीथेन. सो 16 ग्राम ऑफ मीथेन रिएक्ट्स विद 2 into 32 ग्राम्स, क्योंकि 1 मोल ऑक्सीजन में 32 ग्राम्स प्रेजेंट है, तो इसलिए यहाँ पे कितना हो जाएगा 2 into 32. ठीक है. सिमिलरली फॉर कार्बन डाइऑक्साइड इट इज 44, क्योंकि इसका एक ही मोल है, और वाटर के लिए 2 into 80. ठीक है. इन टर्म्स ऑफ वॉल्यूम अगर मुझे देखना है तो मैं क्या बोल सकती हूँ, आपने पिछले लेक्चर में देखा होगा, विच इज द पार्ट 5 ऑफ दिस लेक्चर, वेयरइन वी रिलेटेड मोल्स विद वॉल्यूम. हमने क्या बोला था कि नंबर ऑफ मोल्स इज इक्वल टू गिवन वॉल्यूम by 22.4 liters, right? Since we know that moles is equal to 1, तो यहाँ जब आप 1 substitute कर दोगे तो given volume आपकी 22.4 liters आ जाएगी for 1 mole. That is why it is written here is 22.4 liter of methane reacts with 2 into 22.4 liter of oxygen to give 22.4 liter of carbon dioxide and 22.4 and 22 into 22.4 liter of water. So mass, moles and molecules are interconvertible in terms of data, right? So one more thing you have to keep in mind is the relation between density and mass and volume, because many a times in questions you are provided with the data of density. So you must recall this relation that density equals to mass upon volume. Now let us try to solve this question. It says calculate the amount of water produced on combustion of 16 gram of methane. So as per the question, we are provided with 16 gram of methane. So can I say that W, that is given weight of methane, is 16 gram and molar mass of methane is what, 16 gram only, right? That means अगर मुझे इसके number of moles calculate कर रहे हैं, it is given by W by M of methane, so it comes out to be 1, right? That is why I have written here that 16 gram of methane implies 1 mole of methane. So as you can see in the reaction that 1 mole of methane will give 2 moles of water. So the number of moles of water obtained is 2. So if you substitute in the formula that 2 equals to weight of water divided by molar mass of water, so the net answer that you will get is 36 grams of water. So this is how you will deal with stoichiometric related questions. Let's talk about limiting reagent. So the reactant which gets consumed and limits the amount of product formed is called as limiting reagent. ठीक है, so limiting reagent हम define करते हैं in terms of reactant. ठीक है, तो हम क्या करेंगे, ऐसा reactant जो पहले consume हो गया, मतलब वो खत्म हो गया reaction में, तो वो ही reactant govern करेगा कितना amount of product form हुआ है, और उसी reactant को हम limiting reagent बोलेंगे. जैसे सपोज मेरे पास एक रिएक्शन है A plus 2B gives C plus 3D. तो अब मेरे पास दो रिएक्टेंट है A और B प्रेजेंट है, ठीक है. इनका मुझे कुछ गिवन अमाउंट दिया होगा कि ये डाला, सपोज X डाला और ये Y डाला, ठीक है. जो पहले खत्म हो जाएगा वो ही मेरा लिमिटिंग रिएजेंट कहलाएगा. अब कैसे हम पता करेंगे लिमिटिंग रिएजेंट के लिए, उससे पहले आपको पता होना चाहिए दैट ये लिमिटिंग रिएजेंट का कंसेप्ट कम्स इनटू पिक्चर when reaction involves 2 or more reactants. Definitely minimum 2 reactants तो होने ही चाहिए, out of which हम बताएंगे कि कौन सा limiting reagent होगा, right? So how to check limiting reagent? पहले तो आप देख लो equation balanced है या नहीं है. Then calculate the ratio of given number of moles of reactant and their respective stoichiometric coefficient. The one having lower value of this ratio is considered as limiting reagent. ठीक है, तो उस रेशियो को हम लिमिटिंग रेशियो बोल देते हैं. आपको ऑलरेडी गिवन मोल्स पता होंगे रिएक्टेंट के, उनके स्टोइचियोमेट्रिक कोएफिशिएंट से आपको डिवाइड कर देना है. जिसका रेशियो कम आएगा वो आपका लिमिटिंग रिएजेंट होगा. Let's try to understand this concept with a question. It says in a reaction A plus B2 gives AB2. Identify the limiting reagent when 2 mole of A is mixed with 3 mole of B, right? So first you will write the corresponding equation, then write the stoichiometric coefficient. Here A has the stoichiometric coefficient 1 and B also has the stoichiometric coefficient as 1. Now you are provided with given number of moles. किसके दिए हुए हैं, A का 2 दिया हुआ है और B का 3 दिया हुआ है, ठीक है. तो जब हम लिमिटिंग रेशियो निकालेंगे तो वो क्या होता है, गिवन मोल्स डिवाइडेड बाय स्टोइचियोमेट्रिक कोएफिशिएंट, व्हिच मींस A के लिए 2/1 हो जाएगा और B के लिए 3/1 हो जाएगा. नाउ एज यू कैन सी 2/1 इज लेस देन 3/1, देयरफॉर A is your limiting reagent. Similarly, if in the second part it is given 300 atoms of A and 200 molecules of B. So रेशियो अगर हम निकालेंगे तो A के केस में 300/1 हो जाएगा और B के केस में 200/1 हो जाएगा. So B वाला रेशियो is less, therefore B is your limiting reagent. So if you have understood how to identify the limiting reagent, let us now switch to reactions in solutions. So basically majority of reactions are carried out in solutions. So it is important to understand how the amount of substance is expressed when it is present in the form of solution, right? So first let me tell you about solutions. Solutions are homogeneous mixtures which are of uniform composition. We have already discussed about mixtures in our lecture 1, right? The solution has two components. One is defined as solute and the other one is called as solvent. In order to identify like which substance will be called as solute and which will be called as solvent, you have to check the number of moles. The species having less number of moles constitute solute, whereas species having greater number of moles constitute solvent. Calculating number of moles is very important because many a times students what they do is that they see the masses of the substances given and immediately regard as the lesser mass one as solute and the greater in mass one as solvent, but they end up doing wrong. So let me explain this with the example. Like it is given 80 gram of H2SO4 in water. So if you see by mass, then you can say that 80 gram H2SO4 is there and 20 gram water. तो आप क्या सोचोगे कि 80 ग्राम ज्यादा है, that means H2SO4 मेरा solvent हो जाएगा और 20 ग्राम water मेरा solute हो जाएगा. But you will end up doing wrong. You have to check moles. So अगर आप number of H2SO4 moles of H2SO4 निकालोगे तो वो क्या हो जाएगा 80 divided by 98, whereas number of moles of water क्या हो जाएगा 20 divided by 80. As you can see that this number is already greater than 1, whereas this ratio is less than 1. So number of moles of water is greater than that of H2SO4. That means आपका जो H2O था, water जो था वो आपका solvent होगा, ठीक है? So always check number of moles, right? So a solution has a concentration, right? And its concentration can be expressed in terms of various concentration terms. We will discuss them one by one. First term is mass percent or weight percent. It is represented by percentage W by W. And it is given by amount of solute in grams divided by amount of solution in grams into 100. Now you know that a solution comprises of solute and solvent. तो अगर आपको mass of solution निकालना है, that will be equal to weight of solute plus weight of solvent. You can also do a question in order to understand more. A solution is prepared by adding 2 gram of substance A in 18 gram of water. Calculate the mass percent of solute. ठीक है? That means 2 gram of substance आपका solute दिया हुआ है और 18 gram of water आपका solvent दिया हुआ है, ठीक है? तो mass of solute WA कितना हो जाएगा 2 gram. Mass of solution कितना हो जाएगा WA plus weight of water, right? So total weight of solution comes out to be 20 grams. तो percentage weight by weight of A क्या हो जाएगा weight of solute which is 2 gram divided by weight of solution which is 20 gram into 100. So net percent comes out to be 10%. Another concentration term is mole fraction. It is represented by the symbol called as chi. It is defined as the ratio of number of moles of a particular component to the total number of moles of solution. ठीक है? कैसे निकालेंगे? Suppose I have a solution comprising of A as solute and B as solvent. तो अगर मुझे mole fraction of A निकालना है, so it will be given by chi A equals to moles of A. जिस भी component के moles निकालने हैं वो numerator में आएगा divided by total moles of solution. So here A and B are present in solution. That is why total moles of solution क्या हो जाएगा Na plus Nb. Similarly अगर mole fraction of B निकालना है तो वो क्या हो जाएगा numerator में Nb upon total moles which is Na plus Nb. So since you know that mole fraction is a fraction, right? So its value varies between 0 and 1. Next concentration term is molarity. So how do we define molarity? It is the number of moles of solute present in 1 liter of solution. ठीक है? It is represented by capital M symbol. ठीक है? और फॉर्मूला क्या हो जाएगा हमारा M equals to number of moles of solute. So it will be given in moles, right? And volume of solution. इट इज गिवन इन लीटर्स, ठीक है। तो यूनिट क्या हो जाएगी, मोल्स पर लीटर, या हम इसको मोलर भी कहते हैं, रिप्रेजेंटेड बाय कैपिटल एम। सो मेनी अ टाइम्स क्या होगा कि आपको मोल्स ना देके उसका वेट दिया होगा, तो मोल्स आप कैलकुलेट कर लेंगे कैसे, वेट डिवाइडेड बाय मोलर मास से, ठीक है। अब कोई मुझे बोले कि 1 मोलर NaOH प्रेजेंट है, उसका क्या मतलब हुआ कि 1 मोल NaOH इज प्रेजेंट इन 1 लीटर ऑफ सोल्यूशन, राइट। So let's try to solve this question. It says calculate the molarity of NaOH obtained by dissolving 4 gram in 250 ml of solution, ठीक है। तो मास ऑफ NaOH हमें कितना दिया हुआ है, W 4 ग्राम्स दिया हुआ है, ठीक है। वॉल्यूम ऑफ सोल्यूशन क्या दी हुई है, 250 ml दे रखी है, ठीक है। तो इसको आप लीटर में कन्वर्ट कर लो, तो क्या हो जाएगा 250 डिवाइडेड बाय 1000 लीटर, right? So which is equals to 0.25 liter. You have to take care of the units. The volume of solution if is to be reported in liters. So number of moles of NaOH will be equal to given weight of NaOH divided by its molar mass. तो given weight कितना दिया हुआ है 4 और molar mass कितना होता है 40 होता है इसका, तो number of moles कितने आ जाएंगे 0.1, ठीक है। So when we will substitute this in the formula of molarity, which is equal to number of moles of NaOH divided by volume of solution in liter, तो वो क्या हो जाएगा 0.1 divided by 0.25, right? And it comes out to be 0.4 moles per liter or simply 0.4 molar. Next concentration term is molality. It is represented by small m. Okay. So what is molality? It represents the number of moles of solute present in 1 kg of solvent. This is very important as you need to take care whether in the denominator solution is coming or solvent. So यहाँ पे आपको mass of solvent लेना है in kg. So molality का formula क्या हो जाएगा, number of moles of solute divided by mass of solvent in kg, right? So the unit is going to be moles per kg or molal. Let us try to solve this question. It says the density of 3 molar solution of NaCl is 1.25 gram per ml. Calculate the molality of the solution. ठीक है, तो हमें क्या दिया हुआ है, NaCl का सोल्यूशन दिया हुआ है। That means हमारा जो सोल्यूट है वो NaCl है और हमारा जो सॉल्वेंट है वो वाटर है, ठीक है। मोलालिटी का फॉर्मूला क्या होता है, नंबर ऑफ मोल्स ऑफ NaCl डिवाइडेड बाय वेट ऑफ सॉल्वेंट बताना है विच विल बी वाटर इन kg, राइट। अब 3 मोलर NaCl दिया हुआ है क्वेश्चन में, इसका क्या मतलब हुआ कि 3 मोल्स प्रेजेंट है 1 लीटर सोल्यूशन में। That means number of moles of NaCl is 3, whereas volume of solution is 1 liter, which is 1000 ml. तो अगर मैं weight of NaCl निकालूं, वो क्या हो जाएगा, number of moles of NaCl into molar mass of NaCl. So if I calculate it, it comes out to be 175.5 gram, right? So अब हमें क्या दे रखा है, density of solution दिया हुआ, तो वो किसके इक्वल हो जाएगी, weight of solution into divided by volume of solution, ठीक है। तो वो क्या दी हुई है 1.25 ग्राम, so that will be equal to weight of solution divided by 1000 ml. ये हमें molarity से पता लगा, right? तो weight of solution कितना आया 1250 ग्राम। अब अगर मुझे weight of solvent निकालना है, तो वो क्या हो जाएगा, weight of water plus weight of NaCl ही बनाएगा total weight of solution, right? weight of NaCl हमें पता है और weight of solution हमने निकाल लिया, तो उनको अगर सब्ट्रैक्ट कर देंगे तो हमारे पास वेट ऑफ सॉल्वेंट आ जाएगा, ठीक है। तो वो कितना आ गया 1074.5 ग्राम। अब कुछ नहीं करना, मोलालिटी के फॉर्मूले में सब्स्टिट्यूट करना है, बस ध्यान का रखना है ये जो हमारा वेट आया इट इज इन ग्राम, तो इसको हम कन्वर्ट कर लेते हैं इन केजीज, राइट। तो ये हमारा केजी में हो गया। तो मोलालिटी के फॉर्मूले में जब सब्स्टिट्यूट करेंगे तो नंबर ऑफ मोल्स ऑफ NaCl कितना हो गया 3 मोल, और वेट ऑफ सॉल्वेंट इन केजी कितना हो गया 1.0745 किलोग्राम। तो नेट मोलालिटी हमारी कितनी आ गई 2.79 मोलर, राइट। सो I hope you are through with this chapter. Now try to solve the mock test after watching the videos, as it is available on the EduRev Infinity program. You can also access over 10,000 questions for practice, and also you can give access all subjects in just one subscription. So guys, do try all solving the questions and tests, and do enroll yourself to this program as it is very helpful. So stay tuned. Thank you.